In your notes, we were introduced to some simple principles that will help us determine the ages, the relative ages of some geologic events. We had superposition, where older rocks are always under younger rocks. Whenever we see a series of sedimentary rocks, we know the oldest rock is at the bottom and younger at the top. Original horizontality, any folds or faults that happen in a rock or tilting must happen after the rock is deposited. And sedimentary rocks are always deposited horizontally. So if you see some sedimentary rocks that have been tilted, we know that that must have happened after the rocks were there. The same thing is true about igneous intrusions and faults. Any rock that gets intruded or faulted, the rock must be older than the intrusion or the fault. We talked about contact metamorphism. When lava or magma touches a rock, it's going to create a zone of contact metamorphism. We usually show that with these little tick marks. The rock has to be there in order to get burnt or have contact metamorphism. So anytime we see contact metamorphism, we know the rock that has contact metamorphism must be older than the igneous intrusion that caused it. And then finally, we talked about unconformities, how rock can be weathered and eroded away, creating a gap in time in the rock record. Using these principles, we can then find the relative ages of a series of rocks. Let's take a look at cross-section A. In the following diagram, number the formation of the units or features in their correct chronological order. Place the letter of the oldest unit on the bottom of the list and the letter of the youngest unit on the top, and fill in the rest appropriately. All right, let's take a look. Before we start thinking about what's older and what's younger, let's simply look at what we have. I definitely see some sedimentary rock layers, such as this layer here, which is a limestone called J. Here's a shale called K. We have a layer B and N as well in there, D and M. Some other sedimentary layers that are tilted even more. There's an igneous intrusion A, and there's also a fault that's labeled H. Almost everything in this diagram, in this cross section, has been tilted, some more than once, except for one young layer, and that's layer F at the top. Notice F has not been tilted, and F is also at the top. That's going to be our youngest layer. Down here at the bottom, I got this igneous intrusion. And a lot of times we just automatically go, oh, if it's at the bottom, it's got to be older. But that's true for sedimentary rocks, but not true for igneous intrusions. Notice that A has contact metamorphism in all of these layers over here. All of these layers have some contact metamorphism. So I can't have A happen right away. I need to get all of these layers first, then A. A, igneous intrusion A, does not have any contact metamorphism with N. A does not intrude into N. So N must come after or is younger than A. So I'm going to have my oldest layers will be these, then I get A, and then after A is N, K, and B. N, K, and B, with B being the youngest of these three because it's on the top. K is younger than N because it's on the top of N. So I can put N, K, and B there. And then I have igneous intrusion A. A does not burn those, so A must have come before that, but it burns everything else, so it's got to be younger than everything else. So the only things that A does not burn, it does not burn N, K, B, or F. So N, K, B, and F must be younger than A. So there's my igneous intrusion A. All right, let's see if we can get what's going on over here. I've got E, G, L, and C. E, G, L, and C are the oldest. Then they were tilted. We have this fault H. The fault cuts through E, cuts G, cuts L, and cuts C, but it doesn't cut M. So that means the fault has to come after E, G, L, and C, but the fault was before M. So I better make sure before I get M in here that I get this fault H. It's got to be older than M. Now I've got 1, 2, 3 left for M, D, and J. And we know that between M, D, and J, M is going to be the oldest, J will be the youngest. So here we have the sequence of events and formation of layers that formed this geologic cross-section. Number 1 says find 2 rocks or events that you can determine their relative ages using the principle of superposition. So superposition let us know that older rocks are on the bottom and younger rocks are on the top. And we have a number of different options here. I'm just going to use N and K. I know N is older than K. N has got to be older than K because N is below K. The next question says find 2 rocks or events that you can determine their relative ages using the principle of original horizontality. How do I know the one thing is older than another based on the fact that rocks are deposited horizontally? I think the best one to use here is I know that F is younger than K because F was not tilted and K was. Our third question says find 2 rocks or events that you can determine their relative ages using the principle of cross-cutting relationships. So we want to find something that gets cut by something else. We do have a fault here. We have fault H, and we see that H cuts through this layer L. So there's layer L, which is the shale here as well as the shale here. Since H cuts L, L must be older than the fault H. And finally, find 2 rocks or events that you can determine their relative ages using the principle of contact metamorphism. So here we are. What about contact metamorphism? And we have some contact metamorphism with A and a whole number of rock layers. For us, I know that J is older than A because A has contact metamorphism, but I'm going to go with this one right here. I know that A is older than N because N does not have contact metamorphism from A, or N is younger than A. There's cross-section A. It is time now for you to do one more cross-section. There are 3 more available, cross-sections B, C, and D. Please choose the appropriate cross-section based on your last name as to which cross-section you're doing. You're only doing one more cross-section. You can find them in the folders on the board on the side of the room.